Well, if you go back to my because in engineering, being an engineer is solving problems. I had a problem, okay? You may not be building a building and may not have been designing a computer chip, but it was, in a sense, designing a collegial department, okay? Being an engineer involves complexity, ambiguity, uncertainty, safety, and everything else. And what's the everything else? Well, in this case, the thing that was destroying collegiality within the department. There were wars between the chauvinist and the anti-chauvinist, okay? And in order, in fact, that was the charge I was given when I was selected as department head, was to improve collegiality in the department. And I did, because it was terrible, okay? But so I basically told you about a problem I had and how I went through and used basically the scientific method, collecting data, developing a hypothesis. The hypothesis about African-American PhDs was there's only one in the country each year, okay? And how was I going to hire that person? Well, actually, I did hire one of those, okay? Because he was he was in the second year of graduate school here, okay? And he wanted to go to work in industry, and I convinced him over the next 2 years that he actually wanted to be an academic, okay? Okay, we on? Okay, good, thanks. So I want to talk about, before I get into history, oops, this is not the one I wanted to start with. I wanted to start, oh no, this is the one I wanted to start with. So Boeing, about 20, 25 years ago, got their people together, and what did I do? I just destroyed the automatic focus. There it goes. Came up with a list of durable qualities all engineers should have. Okay, so if we want to say what is engineering, this is not necessarily a definition of engineering, but it's a definition of the attributes of a good engineer. This is what Boeing would like to hire. Someone with a good grasp of science and engineering fundamentals, and we do a pretty good job of teaching that at MIT. Okay? A good understanding of the design process, i.e. understand what engineering is. Engineering is design, taking something that didn't exist and creating it not from nothing, but from other components. Remember, there was a quote that says, engineers don't want to create something new, they want to take the things that already exist and put them together in a new way. I can't remember what the quote was yesterday. A basic understanding of the context in which engineering is practiced. These are all the externalities. Economics. Remember the quote, an engineer does something for $1 that any bungler could do with $2, right? History. I've been giving you some history. Why am I giving you all this history? Well, if you don't understand the context of how you got to where you are, you're not going to solve the problem. And in fact, there's a famous quote from George Santayana. Anybody know who Santayana was? He was a philosopher at Harvard. And he's the one who said, those who cannot remember history are condemned to repeat it. Okay? And I've seen many people repeating history in my life because they didn't know what other people had done before them, or they didn't respect what people before them had done. The manufacturing process. You can design some product, but it has to be manufacturable. And then understanding customer needs, which is marketing. These are all things that an economist would call externalities. These are some of the things that Boeing listed when they got a bunch of their managers who had been engineers. These are the types of people they wanted to hire. People with good communication skills. Why do we have a writing program and all these other things for undergraduates at MIT? Written, verbal, graphic, and listening skills. An ability to think critically and creatively, independently and cooperatively. I handed out that book, Thinking Fast and Slow, and it talks about creative thinking is one of the topics there. Flexibility and ability and the self-confidence to adapt to rapid major change. Well, we haven't gotten into that directly yet, but a profound understanding of the importance of teamwork, or why pointers don't work. Anyway, now there's another definition. I'm going to get rid of definitions here in a little bit, and we'll get into the history of engineering and where it came from and stuff. And this is, engineering involves the application of scientific and mathematical principles. That's the same thing as the first Boeing thing. Design, that's the second Boeing thing. Design, construction, and operation. So it's not just design. Engineering involves constructing things, okay? So in going out there and making it, whether it's manufacturing, whether it's a bridge or a building, if you're a civil engineer, and operation of things like nuclear reactors or whatever. Design, construction, operation of structures, equipment, systems in an economic, efficient, and socially responsible manner. Well, I like this quote because I wrote it 20 years ago, okay? It's part of a report that I was chair of this committee for hiring and promotion of faculty interested in Big E engineering. Big E engineering was something that kind of came out of, we talked about the LFM program a little bit, and that was Big M manufacturing. Well, people started talking about Big E engineering and taking a bigger, broader view of engineering than just the narrow view of analyzing some little component on a carburetor or something and how to make it better. In fact, I did a survey of laboratory directors and department heads and a few deans when I was writing this report, and I asked them, well, one of the conclusions of the report, I said, well, how much do we need to improve the deductive type of reasoning that we teach the students? Or how much do we have to have more inductive reasoning? Well, design is really an inductive process, okay? Whereas studying how a carburetor works is sort of a deductive type of analysis, okay? And it turns out, actually I termed it not inductive and deductive, but integrative engineering versus the deductive type of engineering, okay? And it turns out the consensus, now you have to take a little grain of salt because I was the one who analyzed the responses, but I estimated that people felt that 30% of the students' engineering education should be on the integrative aspects of engineering. You know, how do you put the big picture together as opposed to how do you analyze some detailed component? But they felt that I said, well, okay, how much did you think we should be spending our time on integrative aspects of engineering and how much on the detailed aspects? They basically said it should be about a third of the time should be on the integrative aspects, which are sort of the design aspects. And then I asked, how much time do you think we spend? And they thought we only spent about 15% of the time in your education doing that. So we needed to increase the amount of integrative things. And part of the integrative stuff is a lot of these externalities. Now that report was written 20 years ago, and there's been some movement, but not much, okay, in how we changed the whole field of engineering here. There's been more change over at the management school than there has been in the engineering school. So now I want to talk a little bit about the history of engineering. The concept of engineering has been around since ancient times. And it talks about engineering as sort of mechanical engineering, pulleys, levers, wheels, okay? Ancient times, they didn't have a lot of computer chips, okay? But certainly making computer chips is a big part of engineering today. Modern definition in engineering, exploiting basic mechanical principles. Whoever wrote this for Wikipedia thinks of engineering in terms of the fact that over 20% of all engineering degrees are mechanical engineering degrees, and a lot of the others, whether it's petroleum engineering or whatever other people brought up yesterday, those types of engineers are often dealing with mechanical things. In fact, since this is a course in both a course 2 and a course 3 number, it turns out I showed you that mechanical engineers are involved with, or the degrees are over 20% of all engineering degrees. Well, it turns out in materials, there was a study once that even though materials engineers are about 1.25% of all degrees offered or received in engineering, it turns out about 25% of all people working as practicing engineers are basically acting as materials engineers. If you're a civil engineer and you are selecting the materials to build a new building or bridge, you're basically doing materials. You're doing material selection. And they found that 35% of all other engineers, so 25% were directly involved with materials, another 35% were indirectly involved with materials. So 60% of all engineers end up working on materials. You can say that probably 75% of all engineers are doing mechanical type things. When I was department head and I sat on engineering council, I used to point out course 3 was the only department in the School of Engineering that didn't have a material subgroup. If you go over to, in mechanical, right? Do they still use SUD systems and solids? Have you ever heard that? They divided their department into the 3 S's. SUDS, which is fluids, okay? Systems, which is systems engineering, and solids, which is solid mechanics, right? And stuff. But that's what anyway. So they had their solids was basically a materials subgroup. The head of chemical engineering used to get really upset with me whenever I said that, but he did have a material subgroup, okay? But that's because most engineers, except software engineers, are actually working with materials. I mean, software engineers are working with a computer and bits, but they're one of the only engineers that aren't working with materials. Okay, so let's get into the history, which I've been telling you I was going to tell you about for a while. The history of engineering actually goes back, is what I think I mentioned to you, it goes back to ancient times when the Egyptians were building pyramids, okay? That was mechanical engineering, it was civil engineering, it was whatever, but it wasn't easy to build a pyramid unless you had a lot of slave labor, and they did, okay? But even then, you had to design it, and they had a lot of mistakes, and that's another theory we'll go through about how engineering progresses through mistakes. But then they had the first type of engineering was École Polytechnique in France, and they were military engineers. And I don't know enough of the history of École Polytechnique, but apparently Napoleon, although it must have been someone earlier than Napoleon, but Napoleon supported the engineering because that's how helped him win his battles. In 1802, officially the West Point became part of the first engineering school in the United States, and the U.S. Army Corps of Engineers were in charge of West Point until 1845, before they allowed someone who wasn't an engineer to become head of West Point. In 1824 or 1823, whenever, the Rensselaer School, for the purpose of instructing persons in the application of science to the common purposes of life. And they had 1 degree program, and it was civil. They called it civil engineering to distinguish it from military. I've kind of mentioned this stuff before. Well, it wasn't. There were other schools like Michigan. The University of Michigan claims they had a school of engineering in the 1840s. Well, that might be true, but I don't know what they had for students in Michigan in the 1840s. Maybe the bears were signing up or something, or the raccoons or something. But in fact, civil engineering came about at Rensselaer in 1824. A lot of these in 1860, or a couple of these in 1865. This is how MIT, William Barton Rogers, started to organize MIT in 1865. Course 2 was mechanical engineering. And that was basically how to build machines that made widgets, okay? Whether you're talking about handguns. Who was the guy who developed interchangeable parts? Whitney? Was it Whitney? Eli Whitney was a cotton gin, wasn't he? But who was it? Well, Colt was a little later. But anyway, I don't remember my high school history lessons, but some early manufacturing people were designing machines that made interchangeable parts. They made the cotton gin. They made the Cyrus McCormick made the wheat harvester and things like that. So that was sort of mechanical engineering. It wasn't building bridges and stuff. So we had a mechanical engineering department. Course 3 was mining engineering. Metallurgy had not been invented by 1865. Metallurgical engineering actually came in about 1873 when a guy in England, Henry Clifton Sorby, had been a geologist, and he started polishing metals and etching them with acid, and that's the beginning of metallography. And that's when people started seeing structure in a microscope to metals. Before that, metals were just metals. And also what came along was people like Andrew Carnegie became the richest man in the world. He was richer than anyone today in constant dollars. Steel made Andrew Carnegie the richest person in the world then, and if he had the same equivalent wealth, he would be the richest man today. Okay. Electrical engineering, I pointed out, well, there's one thing I saw, it said 1879, 1880, but basically I pointed out what brought electrical engineering into being, as one student suggested correctly, was we had Edison and Westinghouse basically developed generators for electric lights. And one of them was in favor of AC power, and one of them was in favor of DC power. Who won? Which was which? Edison or Westinghouse, for AC or DC? Edison was DC. He lost. Westinghouse was right, and there's a lot of reasons why AC is better than DC, but mostly it's because you could make motors and things much easier with AC than DC. When you have moving magnetic fields, you can make other things move, and you can make mechanical things. Chemical engineering was invented around 1888. Does anyone know where chemical engineering was invented? MIT, okay? This guy, Arthur D. Little, okay, was one of the chemistry grads at MIT. Chemistry was course 5. Architecture was course 4 at MIT when things started. But Arthur D. Little and some other people, and you don't really know Arthur D. Little now, but he started the first big engineering consulting firm. And essentially, they helped bring the oil business to the world. At one time, the CEO of every major oil company in the world was an MIT grad. Naval architecture, which is no longer a department, but it's part of mechanical engineering, is the 2M program for Marine. Naval architecture was started at various places, but around 1893. Aeronautical engineering, where was that invented? Okay, Hunsaker. Okay, he built the early plane that it was basically a seaplane. I think he was the first person to fly across the Atlantic, although he did hops and skips. He didn't do it continuously. Okay, but after he finished his flight, he came back and started this aeronautical engineering department at MIT, which was the first one. Nuclear engineering. Do we have our nuke here today? She's not here. Where was it invented? MIT. Okay. Manson Benedict in 1958 started a department of nuclear engineering, brought some physicists and some material mining, mechanical people and chemical engineering. He brought a bunch of people together from different departments, and they started looking at how to do things. And then someone said, well, in 1974, this department changed its name from metallurgy, which had entered the department in 1888. In 1974, they changed it to materials. If we go more specifically to Harvard and MIT, someone was asking about the fact I said that Harvard had tried to purchase MIT. MIT wasn't necessarily the third engineering school in the country because Michigan was educating bears or rodents or whatever. But they really were still doing sort of civil engineering, okay, how to build roads and things like that. The MIT, but engineering was coming into its own. Lehigh University had engineering, and Tau Beta Pi became the Engineering Honor Society. Why? Because Phi Beta Kappa thought engineering was a lower skill, a lesser art. And Phi Beta Kappa is for the arts and sciences, and engineering was considered to be the work of machinists and draftsmen and things like that. And what's the arts and science in that? Okay? So this is the hierarchy of snobbery that I talked about. But anyway, it was becoming more popular because the United States was going through this industrial revolution, and engineers were needed for the railroad, building of the railroads and Carnegie steel mills and everything else. So Harvard tried 3 times, starting in 1873, to purchase MIT, and finally in 1917, the Supreme Court of Massachusetts said, nope, MIT is a land-grant college. Anybody know anything about the land-grant program? Okay. There was anybody from Illinois here? Yeah, Illinois. So the University of Illinois, in the center of campus, there's a plot of corn, right? What's the name of it? Morrill plot, okay? Morrill was a congressman from Illinois, and of course they were involved in the Civil War. This was 1863. William Barton Rogers had gotten the charter to start MIT in 1861, but he had no money. And the Civil War started, and he didn't really have a lot of students either, because they were all going off to get shot. And Morrill decided, and this is the way they built the railroads too, the government they had a lot of land. They didn't have a lot of money, but they had a lot of land, and so they would give land to the railroads. You know, they basically passed a law that if you built a railroad, you would own the land for 100 yards on either side of the railroad. So the longer your railroad, you had a long driveway, okay, or a railroad, but you had the land, and then people wanted to be close to the railroad, so you had valuable land. And that's where the cities built up around railroads and things, or towns and stuff. So the railroads became very powerful because of Congress essentially giving them land or rights of way if they would build railroads. But Morrill decided they could do the same thing to encourage, and it was supposed to be, it was the Land Grant College Act, and if a state wanted to start an agriculture and manufacturing university, there's a number of A&M universities, right? Florida A&M, Texas A&M. A lot of states have an agriculture and manufacturing as a title to one of their universities. Well, those typically were the land grant colleges. Okay, any state could become a land grant college, and it turns out William Barton Rogers went down to the State House here in Massachusetts and said, "I'm not a state university, but will you give us the Land Grant Act, and we'll get the money, we'll get the land from the government, and we'll build MIT." And they did. And MIT is the only private university in the country that is the land grant college. There are 50 land grant colleges, but only one is a private university, and that's MIT. Well, the reason Harvard couldn't buy finally in 1917 was because the Supreme Court of Massachusetts said you can't use the land grant charter and transfer it to another private university. Well, they did in the beginning, but nonetheless. And they started their own school of engineering, and it turns out they built it on land that Andrew Carnegie had given them $100,000 to buy in Allston, right across the river. It's now known as the Harvard Business School. At the time, in 1921, when the Harvard Business School opened, there was really no difference between engineering and management. Okay? Frederick Taylor, who was the father of industrial engineering, he was a faculty member at Harvard Business School in 1921. He did time and motion studies, okay, in manufacturing plants to become more efficient as people would carry bricks from here to there and stuff. He did studies like that. Where did he do it? He did a lot of his work over here at Watertown Arsenal, which is now a mall, but at the time was the U.S. Army Manufacturing. They were making parts for the military. It was a big factory over there. So what happened was between 1914, when MIT and Harvard the third time signed an agreement, MIT was in the throes of building this building you're in, okay, in 1914. This building was actually not until 1917, but officially MIT moved over from Kenmore Square at about 1916. And some of these buildings were still under construction. The ones on Mass Ave were 1916. But MIT was building these buildings, and Harvard kind of saw this as this would be their engineering school down Mass Ave, right? But then they couldn't buy it. What was I going to tell you? Oh, between 1914 and 1917, the students at both Harvard and MIT were getting a degree from both institutions. How about that? That's a way to cut your tuition in half, okay? And the idea was they were going to formally merge, and the faculty merged, okay? And I know part of this history because the guy who founded the American Welding Society was a professor of engineering at Harvard. And when I had to give a lecture named after him once, and I looked up his history, and it turns out he was an MIT faculty member from 1914 to 1917. He never left Harvard, okay, but he was an MIT faculty member for 3 years. Anyway, so, but the problem was MIT was expecting the merger with Harvard to solve the problem that MIT was bankrupt for building these buildings. Okay? Anybody know what happened to get MIT out of hock? Yeah. It wasn't, well, it was the founder of Eastman Kodak. It was, and now I can't remember his name. Eastman, George Eastman. Okay. Yeah, okay. He never married. He never had any children. He had a lot of money from founding Kodak. And Building 6 is the Eastman building, okay? And he gave $6 million, which was a huge fortune. It would be like $100 million today. And he got MIT out of hock. But he gave it anonymously, okay? They didn't find out until he committed suicide in 1929 and I think he committed suicide. He was one of the people when the Great Depression came. He was very patriarchal. He cared a great deal about his employees. And when he saw the whole economy falling apart, he just took his own life. And anyway, somewhere in there, we learned that he was the benefactor that got us out of hock, okay? Then there was all the science and engineering that helped win World War II. We've talked about that. There's lots written on those things. In 1950, Alfred Sloan of General Motors endowed the Sloan School of Management. Alfred Sloan was an MIT grad. He basically went to Detroit and he started putting together, merging these companies like Chrysler and Chevrolet, Chevrolet, Buick, Oldsmobile, Cadillac, Fisher Body, and he basically merged those things together, became very wealthy, and a large part of MIT's endowment goes back to Alfred Sloan. He gave a very large fraction of his fortune to MIT. And part of it went to the Sloan School of Management. They took the Department of Business and Industrial Development, which was doing the same types of things as the Harvard Business School. Over time, the Harvard Business School moved more towards general management, and MIT, Sloan School, started out as an engineering school, and the two of them are very different. Does anybody know the difference between the two of them, the different emphasis? Well, in 1988, I actually took a 9-week special intensive program at the Sloan School, and we were going to have lunch or dinner with the Harvard Business School Executive Education Program folks, or some of them. They came down to MIT's Endicott House, and we went up to Harvard just to get to know each other. And one of the guys asked Ed Schein, who was a faculty member over in the Sloan School, organizational behavior was his specialty, says, what's the difference between MIT Sloan School and Harvard Business School? And Ed got up there, he says, well, Harvard's sort of the West Point of business schools, and MIT is sort of the Bell Labs. And that was a perfect description, because at West Point, they teach you how to do it. You'll study, this tank war, the Egyptian-Israeli tank war of, what was it, 1973 or whatever, and how the Israelis wiped out the Egyptians in 3 days or whatever. And they tell you how it's done. At Harvard, they do the case study. In the case study, they're telling you, well, this is what happened, right? And they're telling you the history of what happened, and you're supposed to figure out how to run a business based on studying the history of mistakes and successes and stuff. At the Sloan School of Management, most of the faculty there have never been to business school, okay? I think that one time someone did a check, and only 20 or 25% of the faculty at the Sloan School had management degrees, okay? Most of them came out of MIT engineering. And Sloan is known as having the top programs when it comes to quantitative. So the finance program or the operations research program, Sloan is at the top of some of these areas where you use the mathematical skills. You can solve the partial differential equations, right? There's other differences. One of the other differences is Lester Thoreau, back in the late 1980s, became dean of the Sloan School, and Lester was an economist, but he was in the Sloan School, and he His colleagues called him less than Thoreau, okay? But Lester, at the time, this is like 1988, he was making $30,000 a lecture going to some place like General Motors and talking to their board of directors, giving a 1-hour lecture for $30,000, right? Not a bad good. Sort of like Bill and Hillary going on and doing this for $200,000 today. But Lester was at that level, and I remember Lester was one of the ones who, and this being in the senior executives program, that sort of listening to him changed the way I started to change the way I did teaching. Lester came in and he gave a first talk to us. This was a 9-week program. After about 2 weeks, he came in to talk to 50 of us, and we were all just enamored with Lester. I mean, how did he get $30,000 a lecture? Because he was just an engaging lecturer, okay? And Lester, he'd get up and he talked without overheads. His notes consisted of a 1 3x5 sheet of paper, or a note card with some little words, about 10 or 15 words written on that, and those are the topics he was going to talk about. And as a speaker, he didn't want you looking at the screen. He wanted you focusing on him, okay? And when he got up, he was just very dynamic. And afterwards, everyone in the room, wow, wasn't he great, And so the second time he came in, about 4 weeks later, everyone else was just, oh, we got it. They were listening to him. I'm the engineer. I'm sitting there and I'm saying, oh, what is he doing? How is he doing it? And at the end of his second talk, I thought, he didn't say anything I didn't already know. Most of what he said was very simple, but it was the way he said it. Okay, this is the communications thing. And he was making a lot of money for communicating things well. And to give you an example, I heard him a couple of years later. He was still dean at the Sloan School, and he was over at the Cambridge Marriott Hotel. He was giving a talk to a bunch of people, Sloan School alumni or something. And he was lamenting the fact that the big rich business school up the river would come in and hire some of our best business school faculty. This was one of his biggest problems as the dean of the Sloan School, was trying to hold on to some of the Sloan faculty. Anybody know about the pay scales of faculty at MIT and most other universities? The people in humanities make half of what they do in engineering or science, and the people at the Sloan School make twice of what they do in engineering or science as a salary. I'm not kidding, okay? So there's a factor of 4 difference in scale. So you want to be a professor of music, and you can make a little bit more, maybe not quite as much as a high school music teacher, okay, as a faculty member at MIT. You might be a great composer, okay, but you're in the humanities, and the competition there's lots of people who want to go study medieval history. There's not a lot of jobs for them, okay? The engineers, we have our pay scale, but the management guys have their pay scale. And Harvard's got enough money, they could lure some of those people away. So Lester's complaining about, or lamenting that he loses some of these people. And a lot of people knew that one of the people he's talking about was Robert Merton. Anybody know who Robert Merton was? Anybody heard of Black Scholes? Okay. What's Black Scholes? I'm seeing a little response down there.
I think you mentioned it last time.
Yeah, okay. Well, Black and Scholes were 2 faculty members at Sloan, and Merton was the graduate student, and the 3 of them came up with derivatives, okay? I'm not talking Isaac Newton derivatives. I'm talking about derivatives as of trading, okay? Predicting the value of stock in the future based on the volatility and the current price of the stock, okay? And they had mathematical formulas, typical MIT. You could write down a specific formula and you would get a specific number of what the value of that stock is today based on its past history and mathematical variations in the price of that stock and that was called derivatives, okay? And it was Black, Scholes, and Merton. Well, Black and Scholes passed away, and Merton got hired away to go up to Harvard Business School. And a couple of years later, Merton won the Nobel Prize. Black and Scholes didn't get it because they were dead, okay? But that's why Harvard hired Merton away. He was obviously going to become a Nobel laureate, and he did. And there's other people like Paul Krugman, who wasn't at the Sloan School, he's in the economics department. Anybody heard of Paul Krugman?
Yeah.
Okay, who's Paul Krugman?
New economic theory or something on those lines.
Yep.
Get given because I'm from India. He publishes one weekly column
In India?
the Hindu newspaper there.
Yeah,
So
okay.
I used to read sometimes.
I used to like Paul Krugman. He would say things very simply, just like Lester Thoreau. For example, one of the things he said, to live well, a nation must produce well. Productivity, or no, maybe he said that one too. He also said productivity isn't everything, but it's nearly everything, okay, when it comes to economics and production and stuff. And so he was sort of like Lester, an economics educator and stuff, and he's on Face the Nation and just like Lester and stuff. He left to go to Stanford. Now he's at Princeton, back at Princeton. But Paul Krugman is and actually they've talked about Paul Krugman potentially winning the Nobel Prize. Okay, as far as that goes. But Lester Thoreau was lamenting the fact that he lost certain faculty. But he said, but fortunately, they tend to hire our extinct volcanoes. Okay? Now, do I have to explain what he meant by an extinct volcano? Okay? So he used metaphors that just made things obvious to, he was a communicator, okay? So that changed my life in 1988. I started thinking, oh, you don't have to have fancy, complex things. You just say what everyone knows, but you say it in a way that's memorable, okay? So for example, at the time I was still kind of a guru in welding, and they hold this welding conference every 2 years in Tennessee, Gatlinburg, Tennessee, because the guys at Oak Ridge would organize it. And I've been the keynote speaker for the last 3 conferences, okay? And actually, they changed me from being the scientific keynote to being the after-dinner keynote when all the spouses were there, okay? Because I had learned to start talking like Lester. For example, in 1989, I gave a keynote, the scientific keynote, and I was talking about resistance welding, which is how they put automobile sheet metal together. And so I was giving this talk, and I said, they put 3,000 spot welds in the average automobile because you need 2,000 good ones. Okay, well, I'm trying to make a point about the quality of spot welds and the inability to inspect them and stuff. A year later, I'm at another welding conference, and it's a little cocktail mixer party, and I hear someone behind me say, they put 2,000 spot welds in the average automobile. They were quoting me, okay? Why? Because I said it in a memorable way. If I had just gotten in and started talking about, well, 67% of the spot welds are good, and we have 33% bad, who would care, right? So it sort of changed, not only that, but it changed the way I taught. And now I tell stories, okay, and things, because it turns out you'll remember those things, okay? So communication skills are important. And then there was a big change after 1957. The Russians launched Sputnik. That was a wake-up call for the United States. We thought we ruled the world in science and technology after World War II. We did produce 75% of the world's steel in 1945. Anybody know why? Yeah, from last term, right? Yeah, we bombed them out. That is the best way to beat your competition. Send a B-52 over, okay? Bomb them out. They're gone. They won't be selling that product over here. But yeah, and then 25 years later, we made 25% of the world's steel. Anyway, but now going to this snobbery of engineering and how engineering is perceived. This is Francis Walker, the president of MIT in 1891. Too long have our schools of applied science and technology, meaning MIT, been regarded as affording an inferior substitute for classical colleges. The Princetons, the Yales, the Harvards, right? Too long have the graduates of such schools been spoken of as though they had acquired the arts of livelihood at some sacrifice of mental, intellectual culture, or grace of life. They treated us like nerds in 1891, and they still do, okay? And there's a reason, there's part of a reason for that. Some of you are nerds. Some of us are, I'm sorry, some of us are. William Walker, who was actually one of the founders of chemical engineering, and I think Francis Walker is the one who Walker Memorial is named after. But anyway, this guy was a chemical engineer. There is with scientific men a general awakening to the fact that the highest destiny of science is not to accumulate the truths of nature in a form no one but a select few can utilize, but that the search for truth can be combined with a judicious attempt to make the truth serve the public good. So there was a question yesterday, about the difference between Caltech and MIT. And it gets to Walker. Walker had a fierce battle with a guy named Arthur Amos Noyes. And Arthur Amos Noyes was the greatest physical chemist in the United States. He had gone over to Germany back in around 1900, because that's where everyone studied to become the top scientist. Germany was where the top scientists were until after World War II. And so Noyes went over there, became the top physical chemist, and Noyes thought it was absolutely perversion of the academic lifestyle to do anything work with industry. And William Walker was head of the MIT Chemical Engineering Practice School, which is held up today as being one of the great things of MIT, of universities and industry working together. And the two of them had a terrible fight. Noyes happened to rise to be president of MIT, but he still lost the battle of whether you should interact with industry. MIT chose to work with industry. Noyes, having lost the battle, went and he teamed up with a guy named Robert Millikan. Who was Robert Millikan? The Millikan oil drop experiment in physics. He was at the time a professor, I think, at Case Western Reserve University, actually Case Institute of Technology or whatever it was called. And Millikan and he went out to Pasadena, California, and they took over a little school called Throop Institute of Technology. This was in the 1920s or so, I believe. And they renamed it. What do they call it? Pasadena Institute of Technology. Caltech, okay? The mascot of MIT is a beaver. What's the mascot of Caltech? A beaver. I've been told the school colors are also the same. But the difference is Millikan and Noyes were scientists. And so they didn't believe in a lot of industrial interaction. And MIT grew and has tremendous industrial interaction. They had great engineers at Caltech, like Theodore von Karman, who founded the Jet Propulsion Lab, but it was Caltech was and is a culture based on science, discovering things and not necessarily making them serve the public good. I mean, how many spin-off companies do you know of, or have you heard of, that had something to do with MIT? A lot of Silicon Valley is MIT, okay? But you don't hear that much. You hear a lot about Stanford, okay? But how much do you hear about Caltech? Well, part of it is Caltech is a much smaller school. It's about 1/3 the size of undergraduates. But even so, it's partly the culture that goes back 100 years, or nearly 100 years, to Noyes and Millikan, who were fundamentally scientists who didn't think that you had to, they were there to learn, to increase the world's knowledge, not to make it serve the public good. Okay? So that's the history. And tomorrow, can't remember what we're talking about. But anyway, I have prepared it. I can't remember. Okay, thanks.